Hello again. We're going to move on. We're going to talk about how to draw a line of best fit just by kind of eyeballing it. There is a process in doing that, and I'll just go over that briefly. This is lesson 7.6, so let's get started. We have a set of data, and we're going to find the mean of the x's and call it x bar. We're going to do the same thing with the y's and call it y bar. And then we're going to find that point, that x bar, y bar point on the scatter plot, and we're actually going to plot it. And then using that as kind of a focal point, we're going to draw a line that passes through that point and closely matches the rest of the points as best as possible. We're trying to put as many dots above the line and as many dots below the line as possible. So we're just kind of guessing here and getting as close as we can. All right, so here's an example. I've got a bunch of x's and a bunch of y's, and I've plotted that data for you. You can see it's almost linear. There's a pretty strong linear relationship there. I haven't measured how strong that relationship is, but it looks like a positive relationship, and it looks fairly linear. So what I've done is I've calculated the average of the x's, and that's 1.83. I calculated the average of the y's, and that is 28.75. So, by the way, this graph is measuring the height of men who are 65 years old and measuring the length of their ulna. That is like the bottom bone in their forearm, the one that lines up with their pinky. So measuring those two things and finding a correlation. So we found the average height was 1.83 meters and the average ulna length was 28.75. So I plotted that point, and you can see it in red on the graph. And then I just draw a line that comes as close as I can to passing through as many dots as possible. So it may be off by a little bit, but hopefully not by too much. Now we're going to talk about how to interpolate points using that line. It's basically estimating the location of an unplotted ordered pair, or some point that's not actually on the graph, as long as that point is somewhere between the lowest and highest x values and the lowest and highest y values. So for example, estimate the ulna length of a man who is 1.86 meters tall. Well, I don't have 1.86 on my table anywhere, so what I do is I look for 1.86 on the x-axis at the bottom. I follow that up to the graph, and then I follow the graph over to the left until I get to the y-axis, and I read what number that is, and that ends up being about 29.8 centimeters. So that's approximately how long his ulna would be. Opposite of that, if I were given an ulna length and I wanted to know the height of the man that might have that length of his ulna, let's say his ulna was 26.25, I want to know what his height might be. So I follow 26.25 from the y-axis, follow that across to the graph, and follow that down to the x-axis, so kind of going the opposite direction, and I get about 1.74 meters. That's about how tall he would be. Now, extrapolation is a lot like interpolation, but as you can guess from the name, it's going beyond the lowest and highest x values and the lowest and highest y values of my graph or my data set. So if I wanted to know the ulna length of a man who was 2 meters tall, I would take the 2 meter point on the x-axis, follow that up to the graph, follow that over to the y-axis, and I get about 33.6 centimeters. And then reverse that if I wanted to know the height of a man whose ulna was 25 centimeters long. That 25 is much lower than the ulna length that I've measured. So I find 25 on the y-axis, follow that over to the graph, follow that down to the x-axis, and I get about 1.69 meters tall. So that's drawing a line of best fit, just kind of eyeballing it, and then using that line to figure out other values that might belong in your data set. If you have any questions on that, please let me know, and I will see you tomorrow.